Viewers, today I'm gonna show the two-step three-phase grid connected solar PV system. Okay, so first of all we will see the connection diagram. So here we have given in the manual the connection diagram. Grid you can connect with the transformer, then the output of the transformer we have connected with the sensor input. Okay, so here grid is connected with this transformer input. Okay, 230 volt side, and 70 volt side you can connect with this connector to the input of the voltage. Okay, so R, Y, B and N. Neutral is common for the primary and secondary, so R, Y, B, N you can connect it here, and you can connect the now the grid is connected with the voltage sensor. Okay, and in the line you can connect the input of this current sensor. So R, Y, B you can connect the by using the connector with here RYB, you can connect with this RYB. Okay, likewise this you can see here RYB, you can connect here RYB. Then after at the output of this current sensor you can connect the line inductors. Okay, RYB. So here we can connect the line inductors RYB. Okay, so here you can see RYB, and the output of the inductor 0 side is connected with this here the input of this inverter. Okay, so RYB you can connect here. So internally RYB is connected here RYB. Okay, at the inverter middle point. Okay, and also you can connect the short links with negative rail. Okay, VDC to VC, VC to EA, EB, EC. Likewise this you can connect the positive rail CC, CB, CA, then plus VC. Then you can connect this. You do not connect here. Okay, because it is internally IDC is connected. So you can connect VDC to plus VDC to current connect the voltage sensor, and here you can connect this plus VDC to voltage sensor, sorry, minus VDC to minus VDC voltage sensor, and also you can connect this capacitor. So based on this diagram you can connect the DC line capacitor. So this capacitor at this time of two stage we can connect this capacitor. Okay, then after we can connect this gate pulses. Okay, for this grid inverter to this timer 8. Okay, grid inverter controller timer 8. Okay, and also you can connect this current sensor, one voltage sensor, and DC voltage sensor to analog points. Okay, so here we have provided the list. Okay, so as per this list you can connect the analog sensors input. Okay, so likewise this you can connect the grid inverter. After that you can connect the boost converter. Okay, so this is the boost converter. First of all here you can apply the PV input. Okay, then after do not connect this capacitor. Okay, directly you can connect this grid input to plus VC of the voltage sensor, and minus PV to minus VDC to voltage sensor, and do not connect short link in between this two connector, because internally the current sensor of the PV is connected here. Okay, after the output of this current sensor you can connect the short link to the connect the boost converter. Okay, then DC rail is internally connected. Okay, and the output of the boost converter is connected directly with the short links, and you can directly connect PV to plus VDC and minus VDC. Okay, and also do not connect this capacitor of the output of boost converter in the two stage. Okay, so likewise this you can connect this two stage grid inverter. Okay, and also you can see the connection of the controller of boost converter. So here you can see the ADC is connected with this sensor output, and the gate pulses is connected at timer 8. Okay, so also here we can given this data which pin and which voltage and current sensor is connected here. Okay, so likewise this we can connect the two stage grid converter. Okay, and now let's working with this two stage system. Now turn on the system. Okay, So before turn on the system, you can reset the controller of this grid inverter and also reset the controller of the boost converter. Okay, and now you can turn on the first the grid. Okay, let's check any error is not shown here. Okay, and let's check the voltage, grid voltage, because we have connected the transformer. Okay, now by pressing this button PD5, okay, also you can see here the voltage, DC link voltage. Okay, so now by pressing the PD5 button, you can turn on the grid converter. Okay, uh, now now you can see the grid DC link voltage is regulated to 230 volt, and you can see the voltage and current, because we do not apply this current PV output to boost converter, so the current is 0. Okay, we do at this time we don't feed the current to grid. Okay, and you can see here the some values. Okay, Vref is actually tracking. V phase is 70 volt. Likewise this you can verify once. After the verification, full verification, you can set the if you have PV emulator, then you can set the parameters at 1 kilowatt system. If you have PV, then you can connect the PV. Okay, so here we have set this PV parameters. Let's turn on the PV first. Now turn on the PV. So you can see here, once we have turned on the PV emulator, then you can see the power output is 182 volt. Okay, and here you can see the DC link voltage is 230 is regulated. Now by pressing the PD 7 button, yes, first of all you can toggle with the MPPT. Okay, so PD6 button you can press it, so it will working with the MPPT mode, and PD2 LED will indication. Okay, then after you can press the PD7 button to track the power with MPPT algorithm. Okay, let's see the voltage and current, and here you can see it will try to track at maximum power point. Yes, you can see the efficiency will increase, and also you can see the power is tracked. So you can see the algorithm is set at maximum power point, and also you can check the efficiency is 99%. Okay, and here you can see the graph, it will track at maximum point. Okay, let's see the parameters here. It is 153 volt output. System is working with 1 kilowatt. Okay, so 150 volt at 6 ampere current, and here the duty is 35%, and this is the VDC ref and VDC actual, and this is the power, it is on, and here you can see it is regulated to 250 volt, and here you can see we have fed the power to taking power from the PV and fed into the grid. So you can see the voltage and current. Blue one is the voltage, and sorry, yellow one is the voltage and blue one is the current. We have fed the power to the grid, so the current direction will be opposite. Okay, let's check the current. So grid current is 4.4, 4.37, and here is the 4.37. Okay, so likewise this, it is the balance current we have kit, and we have fed the power to the into the grid. Also you can see the system output, this is the voltage. Okay, so likewise this two stage grid connected 3-phase PV system is working. So now we will see the DAC value. Okay, so here you can see the blue one is the channel DAC 1, and yellow one is the DAC 2, and here we have shown the key function. Okay, so by pressing this key we can toggle those things, and here you can see the DAC values. Okay, number of DACs we have given in the deck points. Okay, here there is two decks, deck 1 and deck 2. Okay, deck 1 and deck 2. So based on the deck 1, deck 2, you can observe those values. Now we will see those deck values on the DSO. So it is the first VA and IA. Okay, then IB, IC, IA alpha. Okay, so it is the I alpha, I beta. Okay, ILA. Okay, VA star, VB star, VC star. This is the VA, V alpha, V beta, and the angle. Okay, so likewise this you can observe the different deck values. So likewise this we can observe the different deck values. Here for this boost converter we have provided the over voltage DC link protection. If anything happen and DC link voltage is below the 350 volt, this protection will active. And for this above, and this for this grid inverter, numbers of protection is there: over voltage protection, over current protection, phase sequence protection. So if anything is happen or something wrong, then all the protection will active. Okay, so likewise this two stage solar PV grid 3-phase inverter is working. Thank you.